Good morning everyone. In this video, I am going to discuss few problems based on the properties of fluid, which is module 1 of fluid mechanics. So this video is particularly for numerical solving. I am not going to discuss concepts in this video in much detail because we are covering this video only to make you revise for the exam. So here there are different properties of the fluid. Property is nothing but which is any measurable characteristic of that fluid. Fluid, if you want to know, fluid is nothing but anything which flows. So here, for example, air, water, these are some of the standard fluids. Other than that, there are many other important fluids, oil, or you can see mercury, or any other liquid or gas. Both liquids and gases come under the category of fluids. So here we are going to discuss some properties and then we'll look at the problems associated with those properties. Mostly we'll be focusing on problems. So here the first property of fluid can be like, first property that we are going to discuss is density. So density is denoted by rho. Usually it is denoted by rho. So density is denoted by rho. So density is defined as the mass of the fluid per unit volume of the fluid. Mass is nothing but the matter that is present in the fluid, and volume is nothing but the space occupied by that fluid. So density is defined as the mass per unit volume of the fluid. So here I am denoting mass by m and volume by v. So the unit becomes, mass is in kilograms and volume is in meter cube. In the SI units, if I talk about the density, SI unit will be kilograms per meter cube. Now please note, this density is defined at a particular pressure and temperature. It varies from pressure. If pressure varies and if temperature varies, density will also vary. So for some of these standard fluids like air and water, the density of water I can denote by rho W, and it is 1000 kilogram per meter cube at the standard temperature and pressure conditions. So at 4 degrees Celsius and 1 atmospheric pressure, this is the density of water. So this is what you need to remember, the density of the water is 1000 kilogram per meter cube in SI units. If you talk about in CGS units, it is 1 gram per centimeter cube or 1 gram per cc. This is in CGS units and this is in SI unit. So this is what about density. And then the second property that we are going to discuss is specific gravity. Second property is specific gravity. So specific gravity, I'll denote it by S, or you can denote by SG or G instead. So specific gravity is denoted by S. Let me denote it by SG here. So specific gravity is nothing but the relative density, or you can think of it as the ratio of two densities. Now it is a relative is in terms of the standard fluid. So I can write specific gravity is the density of any fluid. Usually it is a relative density. So density of any fluid to the density of standard fluid. Now what is a standard fluid? Fluids are nothing but liquids and gases. Anything which can flow is a fluid. So both liquids and gases are coming under it. So standard fluid for liquid will be water and for gas it will be for air. So it can be, usually for liquids it is defined as, for liquids I can write here, for liquids specific gravity is nothing but density of that fluid divided by density of water. And for gases, density of that fluid divided by density of air. So I think this is also fine. So specific gravity is a ratio. It will be dimensionless. It is a number basically. So if you talk about the specific gravity of water, it will be what? 1. because the fluid itself is water. So rho W by rho W will come out to be 1. Now the third property that we look at is specific weight. The third property that we look at is specific weight. Again, there are different ways by which you can denote. So I'll denote it by small w. You can denote it by gamma also. So specific weight is nothing but weight of the fluid per unit volume of the fluid. So I will denote it W by V. W is nothing but the weight of the fluid and V is nothing but the volume of the fluid. Now again, weight is nothing but the force that a given mass of a fluid will exert under the action of gravity. So W can also be written as M into G by V. So the units of W or weight will be Newton and for volume it will be meter cube. So the units of specific weight comes out to be Newton per meter cube, or you can write in terms of kilonewton per meter cube also. So this is about the three properties that I have discussed: density, specific gravity and specific weight. Please note I am discussing it at a very basic level and not going into the details. So now again we'll look at the problems which are based on these three properties, that is density, specific gravity and specific weight. Now for each property I'll take in one numerical itself, I'll take the all the three properties. So the problem is you have to calculate the specific weight, that is small w, density and specific gravity of 1 liter of liquid which weighs 7 Newton. So you have to find out the density, specific gravity and specific weight of this fluid which is of 1 liter and which weighs 7 Newton. So simply you can find out very quickly, you can find out the specific weight from here, because you know specific weight is nothing but weight per unit volume. Volume is also given to us and weight is also given to us. So quickly I can find specific weight is nothing but weight per unit volume. Okay, so weight is nothing but 7 Newton and volume is nothing but 1 liter. Now 1 liter is how many meter cubes? 10 to the power minus 5 meter cube. Because I am dealing in the standard unit, so that is why I am writing it in terms of meter cube. So what will be the specific weight? It will be 7,000 Newton per meter cube. So this will be your specific weight. Now quickly I'll just find out the density also. Density is nothing but mass per unit volume, but mass is not given. Okay, so what weight is given? So how can you find mass from weight? So you know W is equals to mg. Basically W is force and m is nothing but the mass of that particular fluid. So whatever force that mass is exerting under the action of gravity, that is weight. So you can find m as W by G. W is equals to mg, so m will be W by G. So here I can write as W by G and here V is there. So simply I can find it as 7,000 by 9.81. Take the value of G as 9.81 meter per second square. Sorry, this is 9.81. So here W by V you have already found as 7,000. So simply you are calculating this and the value comes out to be 713.5 kilogram per meter cube. Okay, mass is in kilograms, so the units will be kilograms per meter cube. Now, the third part of the question is you have to find out the specific gravity of this fluid. So you don't know about this fluid, this or whatever you know about that fluid is the fluid density is 713.5 kilogram per meter cube and its unit weight is this. So definitely if you think of it, density of water at 4 degrees Celsius is 1000 kilogram per meter cube, and density of this fluid is less than that density of water. So you can say it is lighter than water. Okay, so here you can find the specific gravity, which is nothing but ratio of two densities. So ratio of the density of this fluid divided by ratio of the divided by the density of water. So you can find it as 713.5 divided by 1000. So I'm taking under the standard conditions. So the value of this specific gravity will be 0.7135. So like that, many problems you can see, and I'll give one problem to you at the end of this video, and you can try that out based on this similar concept. Please note the value of specific gravity will most of the times be a number, or you can express it in terms of a ratio. Sorry, it is a ratio, so it will be usually expressed in terms of a decimal or a fraction. It will be dimensionless because it is a ratio of two similar quantities. Now I'll give you a problem based on the concept which we have discussed above. So you have to calculate the density, specific weight, and specific gravity of 1 liter of petrol weighing weighing 6.867 Newton. So again, similar type of problem, weight of the fluid is given to you. Fluid is petrol. So 1 liter of petrol weighs this much Newton. You have to find the density of this petrol. You have to find the specific weight and specific gravity of the petrol. So thank you so much. This video was about three properties that we have discussed, and in the next video we will be discussing more properties of the fluid and the problems associated with these fluids. So today we have discussed density, specific gravity and specific weight, and have covered one problem based on this topic. So thank you so much.